This is a snapshot video on Chebyshevs theorem and the empirical rule. It is expected that you have at least looked at my lecture notes and or the book. You should watch the video, but when you come to an example, I suggest you stop the video, try working out the problem, and then play the video and compare what you did to what I did. Basically, Chebyshevs theorem and the empirical rule are associated with a particular type of problem that associates the percentage of the population to that of an interval that is centered about the mean. In other words, I'll draw a little picture here. We have a line representing the number line, and we have the mean mu for the population. You're either going to be given an interval that is centered at the mean, and you're trying to find the percentage of the population in that interval, or you'll be given the percentage and you'll be asked to find an interval that contains that percentage of the population. So that's what's going on here. So, given a problem that's relating an interval to the percent, that's a typo there. I caught it. This is unedited. It is what it is. If I make a mistake, hopefully I catch it. All right. If I don't, please let me know. But anyway, given a problem that the empirical rule and Chebyshevs theorem is associated with an interval and the percentage of the population that is in that interval. So, the first thing we're going to do here is we're going to recall a little basic mathematics. And this is going to be needed when working problems associated with these two concepts. So I'm going to go through two examples and try to get that little math across to you, so this will not be a problem when we actually apply the two techniques. All right, so let's just go to an example here. Suppose that I know the mean for a population is 100 and the standard deviation is equal to 6. I want to find two numbers which are 4 deviations from the mean. I want to find two numbers which are 4 deviations from the mean. All right, so let's draw a little picture here and try to visualize what's going on here. So here's the number line, and here's 100. Now, I want to find two numbers that are 4 deviations from the mean. Well, you know the standard deviation is equal to 6. So if I go out 6 units, another 6 units, another 6 units, and another 6 units, that will be that number, correct? Well, that's 106, that's 112, 118, and 124. If I go in the other direction, 6 units, 6, another 6, another 6, and another 6, meaning 4 deviations, right? Well, if this is 100, 6 units, 94. 6 units, 88. 6 units, 82. 6 units, 76. So here are the two numbers which are 4 standard deviations from the mean. What's more important here, oh, sorry about that. Let me see what happened to my notebook. I must have pressed something. Okay, back at it. Now, if you think about it, what's the distance from 100 to 124? 24, right? That's the distance. What's the distance from 100 to 76? 24. That's the total distance. So notice how distance is related to the number of standard deviations. In other words, what I'm saying here is notice that 4 times 6 is equal to 24, right? So really, I didn't have to actually show you necessarily me moving out 1 standard deviation, 2, 3, 4 standard deviations. I could have just realized that, well, if I want to find that number, which is 4 standard deviations from the mean, I just have to multiply the standard deviation by 4. And so we're going to get an important relationship, and I'm going to give it to you right now. K represents the number of standard deviations. Sigma, we know, represents standard deviation. And we're going to let D represent distance. So the relationship between standard deviation and distance in terms of the number of standard deviations, which is K sigma equal to D. I'll tell you right now, basically you're going to either be finding K or you'll be finding D. You will always be given sigma. So that's really the important relationship that I want to stress here. You're going to be working between these two numbers, K and D, either getting K or getting D. But you need to know the relationship here, that K times sigma is equal to D, or K is equal to D divided by sigma. You're going to be working with one of these two. All right, so again, I'm suggesting you stop the video, work the problem, start the video. All right, I know my mean is 100 and my standard deviation is 6. Well, see, I already forget that. That's going to be corrected when you see that. That's going to be gone. Okay, that's the last problem. All right. I'm given the mean is 100 and the standard deviation is 6. How many standard deviations is 82 from the mean? I want to know how many standard deviations is 82 from the mean. The previous problem, I was looking for these numbers. Now I'm looking for how many standard deviations. It's different. It's backwards, right? So I draw a number line. There's 100. Here's 82. I know the distance between 100 and 82 is 18, right? Well, the number of standard deviations times the standard deviation has to be equal to what? 18. The distance. I gave you that formula right up here. K times sigma is equal to 18. Well, sigma is 6. So K is equal to 18 divided by 6, which is 3. In other words, 82 is 3 standard deviations from 100. How many standard deviations is 115 from the mean? So once again, here's the mean. Here's 115. I'm trying to find the number of standard deviations, not the standard deviation, but the number of standard deviations. Well, I'm given the number now. I know the distance. The distance is 115. Well, again, K times sigma is equal to the distance, right? So K is the distance divided by the given standard deviation, 6. I'm sorry, that should be 15. Divided by the standard deviation, which is given to be 6. Now, K here is not a nice clean integer. It is a decimal number. 15 divided by 6 is 2.5. So K is equal to 2.5. K does not have to be a whole number. K can essentially be any number. All right, so here's this little math formula that's going to be very useful in what we're about to do next. Remember, we're going to let K represent the number of standard deviations. D is our distance. A number is from the mean, okay? Some numbers from the mean, that's the distance, in either direction. And again, sigma is the standard deviation. In all of our problems, you will be given a value for the standard deviation. you will either have to find K, that is when you are given the interval, or D, when you're given the number of standard deviations. All right, so here's Chebyshevs theorem. The percentage of data values that falls within K standard deviations of the mean is given by this formula here, a very important formula. The percentage of data values that falls within K standard deviations of the mean will be at least 1 minus 1 over K squared, where K is a number greater than 1. It can't be 1 because notice you're going to get 0. All right, so this is an important relationship. What we're saying is 1 minus 1 over K squared is tied to the percentage of data in the interval. Remember, we're either going to be finding an interval and given the percentage, or we're going to be finding the percentage and given the interval. It's going to be working one way or the other. If we know K, we have the percentage. If we know the percentage, we have K. So here are two important formulas that we will be working with in the next 2 or 3 examples coming up. And they are the percentage of data in an interval is related to K by 1 minus 1 over K squared, okay? And K is related to the distance by K times sigma is equal to D, which is the distance from the mean to one of the endpoints of the interval. Now, we're going to start working some problems here now, but you have to have these two particular formulas in mind here. Again, these formulas associate the percentage of data in an interval with that interval centered at the mean. So here's our first example. So again, I suggest you stop the video, work the problems, then watch the video. All right, you are told that the mean of a distribution is 20 and the standard deviation is equal to 2. And we want to use Chebyshevs theorem to answer the following questions. What percentage, at least what? Chebyshevs is a theorem that says at least a certain percentage of data, okay? Typically, I'll just simply say what percentage of data, okay? But it's really at least, all right? So keep that in mind. At least what percentage of data values will fall between 10 and 30? All right, so once again, we are trying to find the percentage of data in this interval here. 10 to 30. So we're looking for the percentage of data in here. Chebyshevs theorem relates the percentage of data to that of the interval, but in terms of the number of standard deviations. So notice our mean is 20. It is centered in this interval. So notice that the distance from 20 to 30 is 10. So I know the distance, right? If I want to use Chebyshevs theorem, I either need to know the percentage or I need to know the number of standard deviations. Not the standard deviation, but the number of standard deviations. Now, I know the distance is 10, and we know 10 is related to K times sigma, but sigma is 2. So that tells me K is equal to 5. So I know that K is equal to 5. And if I plug this into Chebyshevs formula, then I get 1 minus 1 over 25, which is 24 over 25. As a percentage, that is going to be 96%. So 96% of whatever I'm talking about here, whether or not it's light bulbs, whether or not it's test scores, I don't know. Whatever, if it has a distribution that has a mean of 20 and a standard deviation of 2, then in the interval that is between 10 and 30, I know 96% of the data is going to be within that particular given interval. Moving on to the next problem, or the next part of this problem. In this one, I want to find a percentage of data values that fall between 12 and 28. So again, I want to find a percentage of data values between 12 and 28. The mean, 20 is, say, located here. I'm looking for the percentage. I know one thing, the distance from 20 to 28 is 8, and likewise from 12 to 20 it's 8. So once again, 20 is centered. All right? It has to be centered on the interval. Once again, the distance 8 is related to k times sigma, which is 2. In this particular problem, k is equal to 4. So if we plug this into Chebyshevs' formula, 1 minus 1 over k squared, we get 16 for a denominator, and we get 15 over 16 is that percentage. And 15 over 16 is equal to, rounded to 2 places, approximately 94%. We got less data because we shrunk the interval a little bit, right? So we should have a less percentage of data in that interval. So here's the problem. We were given the interval, we wanted to find the percentage. When we're given the interval, we can find the distance. When we find the distance, we can find the number of standard deviations. That is what we plug into Chebyshevs' formula to get to the percentage. Chebyshevs' formula allows us to either go from the interval to the percentage, but in our next problem, we're going to be given the percentage. So again, I encourage you to stop the video and work the problem. So stopping, I'm working it. All right. The average number of calories in a regular sized bagel is 240. So I know that the mean is 240. This average word really should say mean. They're getting away from the term average, so that will be corrected. The mean number of calories in a regular sized bagel is 240. If the standard deviation is 38 calories, I want to find the range in which at least 75% of my data is in this interval. I want an interval that has 75% of my data. Chebyshevs' theorem tells me the relationship between the percentage of data and the number of standard deviations is given by 1 minus 1 over k squared, and that's associated with the percentage, correct? Well, now, in the previous problem, I was able to find k because I was given the endpoints and I knew the distance. Well, now I need to find the endpoints. Well, we're going to solve this for k. 1 minus 1 over k squared is equal to 0.75. Now I'm going to switch sides here, so 0.25 is equal to 1 over k squared. Taking the reciprocal, k squared is equal to 1 over 0.25. In order to get rid of the square, we take the square root. So that's going to tell me k is the square root of 1 over 0.25. When I do the math, we get k is equal to 2. So therefore, we know that 75% of the data will be contained within 2 standard deviations of the mean. Well, our mean is 240. So we need to really find the distance here to the endpoints. But again, I told you the distance is equal to k times sigma. Now I know what K is. So D is equal to 2 times sigma, and 2 times sigma is 1676. So if I add 76 to this and I subtract 76 to this, I get my endpoint, or I get my interval that contains 75% of my data. So I did my math, and I got the interval is, I'm going to write this a little bit better here, 164 to 316. That is whatever this, well, number of calories in a regular sized bagel. That is telling me 75% of all bagels will have between 164 and 316 calories. All right, at least 75%. Now that I think is the oh no, we got one more here. Let's get this one out the way. All right, so again, one more Chebyshevs, and I'm gonna stop this video, and we're gonna have another video. Americans spent, stop the video, work the problem, right? So here I go. All right, on average, again, we're getting rid of this average word, and we're going to work only with the word mean. So we're told that the mean number of minutes a person spends on time is 90. The standard deviation is 32. I want to find a range. In other words, I want to find an interval that contains 89% of my data, or at least that much. Once again, Chebyshevs relates the number of standard deviations to the percentage of data, right? That's what Chebyshevs tells us. Well, again, I can solve this for K. 1 minus 0.89 is 1 over K squared. 0.11 is equal to 1 over K squared. K squared is equal to 1 over 0.11. So I take the square root, and we get K is equal to, I would say, approximately 3. Okay? It's 3.015, all right? But I'm going to just simply round to 3 to keep this simple. I will tell you how many places to round, all right, on a test, all right? So anyway, we're going to take K to be 3, just to keep the math easy here, all right? So now I know that at least 89% of my data will be within 3 standard deviations of the mean. Well, here's the mean, 90. The distance now to the end, remember, is related by K times sigma, but K here is 3, sigma is 32, so my distance is 96, right? 3 times 2, 96. So if I add 96 to this, and I subtract 96 from this, okay? Well, if you keep in the context of this problem here, you can't have a negative, but I'm going to just show you. Minus 6 to 186. That's the interval. All right, but in reality, you can't have a negative number, so one would put 0 to 186 there. Okay? Because again, think about the context of this problem. You can't have negative minutes online, right? So let's just review this right quick, and then we're going to move on. Again, I was given the percentage of data, so I needed to find the interval. I know the relationship between the percentage and the number of standard deviations is given by Chebyshevs theorem. I solved this for K. You need to work this out. This is not an algebra class. And I found out that K was approximately equal to 3. The relationship between distance and K is given here. I find the distance, 3 times sigma. I know that now I add this distance to the mean, I subtract it from the mean, and I get my interval. All right, I'm going to stop this video, and then we're going to pick up with the empirical rule.